Good afternoon, everybody. I hope you guys are doing well. Hello, Steve. So, full disclosure, yesterday was short. Today will be even shorter. So we're looking at the chapters. I'm looking at. Let me fucking find it real quick. So yesterday's chapter, getting things out of functions, was only about a half hour of video time. Today's is only like 15 minutes. So it should be a very quick lesson unless barring some horrible misunderstanding, some fucking terrible skill issue on my part. But we're not going to go on to the next one because the next chapter is actually like a decent length. Okay. Unrelated newsflash: the Sonic 3 movie trailer dropped. I've been seeing people talk about it on Twitter. It's been a little bit it's been kind of interesting. I've been excited for it ever since I heard that Keanu Reeves was supposed to be voicing Shadow. I think that's really fucking funny and perfectly fitting, ironically enough, because I really like Keanu Reeves as an actor. I think he's really good. He's a very It's very tense and edgy, just how we like it. Exactly. Exactly. It's perfect. Yeah, I'm thinking we're back. But anyways, let's get this coding kind of well, I don't want to say like out of the way, right? Because I enjoy doing it. Sorry to go off topic. No, it's fine. We don't have a whole lot in the way of coding to do today. I figure we'll go ahead and try to get it done. Try to complete it, and then I can use that as an excuse to. I can use today's relatively short day as an excuse to try and get the Bard's Tale video like done, because I'm like the end is in sight with it. I'm like working on like uh the part that's about like the final floors and my shit with that. I have no idea if I'm gonna be alive for the latest stream. That's fine, man. That's fine. Like I said, like you can't make it to all of them, and you make it to enough of them that it's very that I'm flattered, frankly. All right, let's get this over here. There we go. Boom. All right, let's get rid of this little thing, and let's have him talk to me about function overloading. I'm gonna be I'm gonna be sad if like I pulled up this and it's not even like there's nothing even practical to do. We'll see.
Would like to welcome you in this new chapter where we will be learning about
Gotta offer some
function
support in some
overloading.
weird way, don't
Function
I guess,
overloading
man.
is a mechanism we have in
I
C++
appreciate it so much.
to have multiple copies of the same function but taking different parameters. For example, here you see that we have different functions, but all these functions have the same function name. And these are said to be different overloads of the same function. There are a
Interesting.
couple of rules you need to be aware of to be able to set up your overloads correctly and get them to work. And that's what we're going to be learning about in detail in this chapter. But now I just want you to see the flexibility you can get with function overloading. For example, here, if we have a few variables in our program, we can call the max function, and the compiler is going to select the most fitting overload in here. So for example, if we call our function with integer arguments, the compiler is going to choose this overload here. If we call our function with std string arguments, the compiler is going to choose this overload here, and we don't really need to concern ourselves with making sure we have the correct arguments. The compiler is going to choose the correct function overload for us, and it is going to call it, and it's going to be very flexible to call these functions from our C++ code.
See, okay, because this sounds to me like it violates the one definition rule, right? Like I'm not 100% on that, obviously, because we're learning that we can do this, but I'm curious how we duck that rule to overload something. Can't.
This is how
What the
function
hell?
overload can be really useful. We are going to stop here in this lecture. In the next one, we're going to learn about how you can set up function overloads based on different function parameters. Go ahead and finish up here and meet me there. In this lecture, we're going to see how we can overload functions based on the parameters that we pass to the function when we are declaring it or defining it. And here is a simple example to drive the point home. Here we have a function called max, and this is the name.
All
It
right.
is taking two parameters which are of type int here, and by overloading this function, we will have to use the same name as this function here. So the differences really will be in the parameters that we pass to the function, because the return type isn't involved in defining the signature of the function. So if we try to set up another function called max here, which takes the exact same parameters as our max on top here, the difference is only going to be in the return type. The compiler is not going to allow us to do this because the return type isn't really significant in making two functions different. Okay, the only way we have to set up a function which is legal in C++ is to change something about the parameters that we have here. We can change the types like you see here. For example, we change the types to be double. If the types are different, we might even change the order of the parameters. You just have to make sure the parameter list is different in one way or another. That's how you're going to get this function to run with the same names here. And if we manage to set up
Wait, so the my 1 a.m. streamer. See you on Friday. See you Friday, Picketarian. Today's really short, anyways, so it shouldn't be. I don't know how much you're gonna be missing. It's only like, I think the lesson itself is only like 15 minutes long or something. So we'll be doing something more in depth tomorrow, and probably Friday as well. But it seems like what he's basically saying. So maybe I misunderstood the one definition rule when we did that. But basically, I was under the impression that this name here needed to be different. But I guess it's this and the parameters. Because he did say that, I think he said that it was like this, each thing's signature needs to be different. And I think this is the signature, and then this is just, I think the return type is not actually a part of that.
multiple functions with the same name in C++, these functions are going to be called overloads of each other. Okay, if we go down here, we have another overload for the max function. This overload is going to take two parameters, and the parameters are going to be of type string view. They are different from what we have on top here, which is int. So this is a legal overload for this max function here, and we can use it.
That's
Okay, we
so
really have a
strange
few
to
ways
me.
we can make our function overloads by now. We can change the order of the parameter, we can change the number of the parameters, or even we can change the types of the parameters. Again, function overloads are a mechanism we have in C++ to set up multiple functions with the same name to make our code easier to work with. Okay, now that you know that, let's look at a simple example of how we can call our overloads. We have a few
Yes.
variables declared here. We have int variables, we have double variables, and we have std string view variables. And if you go down here, we are calling our max function passing in integers. So the overload that takes integers for this max function is going to be called here. Down here, we are passing in integer literals. So this is going to call the int overload. Down here, we are calling the function with double parameters or arguments. So this is going to call our double overload for the max function here.
And the
And down
last one,
here, we are
or I
passing
guess
in
two
our
different
string
ones.
view parameters. And this is going to call the overload that takes string view parameters. And the last guy here is going to take two string literals. String literals can implicitly convert to std string view. So our std string view overload for the max function here is going to be called. Now that we
That's
know
so
this, we're going
weird
to
to
head
me.
over to Visual Studio Code and play with this a little more.
All right.
Okay, here we are in our working folder. The current project is overloading with different parameters here. We're going to grab our template files like we always do. We're going to put them in place. And we are going to open this guy in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. This is going to open our project here. We're going to click on our main CPP file and open it. We're going to clean it up a little bit and close the left pane here. We are going to go on top here and put in our first max function here.
All right, let's put in our max function. So the max functions, we're going to be making like 3 different ones by the looks of it. Just so that we can demonstrate this. And I think it's really weird to me. Right, I'm going to go on a quest for food. Sorry if I don't make the stream later. That's fine, man. I hope you're successful in your quest for food. It should be tasty, whatever it is you get. It'll And no worries if you don't make stream, man. I'd hate for anyone to feel guilty about not making it. I I'm happy you want to show up at all.
The return type is
Good
int.
luck
In
on your
this
C++
case, it is
quest.
going to
Thank you.
take two
I will do my
parameters,
best.
and it is going to return whichever number is the maximum. And we are taking parameters in by value and returning by value here. Nothing special. We can go in main and call this function, and you already know how to do that. I don't think I really need to do that. But now, what we really are interested in is being able to set up different functions with the same function name like we have here. Because if, for example, you take this function and put that down below, we're going to make a copy of it. and only change the return type. If we try to compile this program, you see that even Visual Studio Code is unhappy now. If we bring up a terminal, it is going to tell us cannot overload function distinguished by the return type alone. So again, the message is super clear here. The return type.
Wait. So this one should give me that. Cannot overload functions distinguished by return type alone. So return type alone, so that means that, so the way that he showed it here, we don't even have to do both of them by the looks of it. Here, what if I did another one? I'm kind of curious. So this should give me the same issue, I think. So if I do, if I do this, that should also. What if I do like this? Does that do anything? No. Yeah, because it's the same pretty much. So this should be there was this string one. I don't remember exactly what the thing was. We'll just leave it like this. We're going to change this one also to double. But the way that it was the way he explained it was basically just like this, right? You can overload this by changing the output type and the inputs as well. So, but it can't be distinguished by return type alone. That is, I don't know why that's like fucking me in the brain so
Is not
much.
enough to make two functions different because
Yeah,
the
they're
return
not
type
different enough.
isn't involved in making the signature unique. What makes the signature unique is either the function name or the parameters that you pass to the function here. So we're going to make this return type back a double, and we're going to figure out a way to make these two functions different but have the same name here, because sometimes you really want this. One way we have to do this is to change the types of the parameters that we pass in here. So we're going to make them double, and we're going to make them double here, and this is going to be valid C++.
It seemed like
code.
only one of them
These two
needed
functions
to be a
are
double
different.
in order
Even if
to
they
make
have
it
the same
valid.
name here, they are two different functions
So that's
because
kind of
they
cool.
take different parameters. So if you try to call this function with integers, this one is going to be called, which takes integers in. If you call it with double arguments, this guy here is going to be called. Let's try and prove this. So we're going to go inside and say stdc out int overload called. I think this is enough. And we're going to go in the double function here and say stdc out double overload called. Okay, once we have this, we also have to change the return type here to double because it's going to make things a little bit consistent here. But now we want to go in our main function here and set up a few variables. We're going to say int x, and we're going to make this a 4, and we're going to say int y, and we're going to make this a 9. Why not? We're going to set up also double variables. Let's say double a, and say 5.4 to make it a double variable. And we're going to say double b and put in 7.4. Why not? Now we are going to call max. We're going to say auto result and say max and pass in x and y. What do you think we're going to return here?
So when we do this, let's see. We're gonna run through the code line by line, do the rubber ducky explanation type shit. 5.4, and then this one is 7.4. Alright, we're going to do our little rubber ducky explanation. Chat is my rubber ducky. So when we do this, we've created two functions. One which is a integer max, one that's a double max. One of them takes, so the integer max takes two integers, prints int overload called, and then returns if A is greater than B, then return A, else B. So in this case, when we're passing integer A and integer B, it should just pass. We'll worry about that later. And then the function is identical for double, but this one accepts double variables. So that's any kind of decimal, right? Up to a certain point. So here we go into our main function. And then we create an integer called x with a value of 4, and an integer called y with a value of 9, a double value called a with a value of 5.4, and a double value called b with a value of 7.4. Here we're using auto result. We're using an auto, so this is going to create some type of variable of type that will be determined by the compiler. Based on what we put in here. So it's called result, and we want it to be equal to max, which here we've input our values as x and y. So taking this max function into account, we've passed the values x and y. They're both integers, so it should call this one, right? That's the very basic conceit. So what we can do, we'll run the task, GCC. It should just return 9. It should return we don't have anything that prints the actual value. Well, yeah, I guess it doesn't actually matter if it returns 9 specifically. Here, I'm gonna do this myself anyways, because I think, why not? And we'll print it as, it was what? Max int. And then we'll call, and we do this, and then we do, does this work? Oh no, I think what we want to do is print that in here somewhere. Call this max value, and then it prints result. And then this will go based on and this one should just print whatever value is here, which is 9.
What we really are interested in is the return type of the result variable here.
Yeah.
And the compiler is going to deduce whatever is returned by this function. If we call the function with x and y are integers, so the compiler is going to search for a function that takes integers, and it's going to find this guy here, and that's what it's going to be called. Let's build and run this program. We are not interested in looking at the output here.
I was, so I put one in.
These std out statements here.
Look at that, max 9, int overload called.
Okay, we expect the int one to be called, so we're going to see int overload called on the terminal here when we run this program. So let's do that. We're going to build with GCC like we always do. The build is good, so we can clear.
Look at that, we did it.
We're going to see int overload called. Okay, so this proves that we can set up two functions with the same name and make them different only in the
That's very interesting.
That they take. And the differences may be either in the types of the parameter like we are doing here. They may also be in the order of the parameters. And we're going to see an example of that in a minute. But before we do that, we also need to try this with A and B and show you that the double one is going to be called because we are passing in double arguments here. So let's build again. The build is good. We can clear and run rooster. This is going to call our double overload. Hopefully this really drives the point home.
Look at that.
We can set up multiple overloads for the same function.
It works
and again,
exactly as advertised.
In the parameters that we pass here. We have been able to pass different types for the parameters, and this was legal C++ code. But we can also set up another overload just by changing the types and the order of the parameters. Let's do that. We're going to make the first parameter here int, and once we do that, this is different from any of the overloads we've had. So this is a valid overload for this max function here. This is going to work. We can even change the order of these two guys, and it is also going to be a valid overload. Let's put in another variant of this guy, and we're going to change the first parameter to double and the second one to int. And now we have 4 overloads for the max function. And again, the message here is that you just have to make sure the parameters are different in some way and your overload is going to be valid. And again, I'm not telling you to
I
set up
see.
functions like this because in this case, this is really useless. But
Yeah,
I
there's
am
no
trying
reason to
to
do this.
expose this facility to you so that you can use it to your advantage if it makes sense for whatever application you are designing here. So let's go down and put in meaningful output. I think we can come in here and say the parameters that we are passing in here. So we can say int double overload called. And if we go down here, we can take this out and say double int overload called. And to get any of these guys to be called, we have to pass the parameters or the arguments in this order. So if we pass in an int, which is x is an int, and we pass in a double, which is a b here, this is going to call our overload, which takes the first argument to be an integer and the second argument to be double. Let's prove that. We're going to build with the GCC. The build is good, so we can clear and we can run rooster, and we see int double called because x is an int and b is a double. If we flip these guys, let's say b and x, then we're going to have the overload that takes the first argument of double type and the second argument of int type to be called, and that's this guy here. And we're going to see this message printed out on the terminal here. Let's build with GCC to really prove this. So we're going to do that. The build is good. We can clear and run rooster and double int overload called. Hopefully you can
Damn
really
it,
see
Garquaya
that you
Sensei,
can
you
set
have
up
taught
all
me
kinds
something
of
new
crazy
yet again.
overloads for your functions. The next thing I want you to see is that we can even change the number of the parameters. For example, here we can set up another guy here and call it max. It is going to be exactly like the one on top here for the first 2 parameters, but let's add a third parameter. Maybe make it an int and say c. And this is going to be a valid overload for the max function here. So we're going to say double int because it takes 3 parameters. I won't go into the details of how we can compute the maximum between these 3 guys. What I really am interested in is showing you that you can set up overloads here. So for this case, we are just going to return, let's just say a. This is going to work. But this is a valid overload
if you
for
say
the max
so.
function, and it is going to compile. So let's try and do that. We're going to pass in a double, an int, and an int. So we're going to pass in b, which is a double, and x and y. Let's see what is called here. We can compile with GCC. The build is good. We can clear. And please try to come up with what is going to be printed out here. What is going to be
it should just
printed?
say double int
Okay, now
overload
that
called,
you have
right?
guessed, we're going to run, and we're going to see double int because this is going to call this overload. Again, you can overload based on the differences in the types of the parameters that you pass. You can change the order of the parameters like we are doing here, double int and int double, or you can even change the number of the parameters. Using these techniques, you can make sure that your overloads are different in some way. Before I close this lecture, I'm going to show you that you can also use another overload that takes string view parameters. Let's go down here and put that in. Again, the name of the function is max. The return type isn't really meaningful in making sure 2 functions are different, but watch the parameters we pass here. The types are string view, and we have a and b here, and we are going to compute the maximum. So if we go down here and say max and pass in hello and world, the compiler is going to try and look for a function that takes 2 character array parameters.
Hold on. Okay. So we go to here, and then it's return a, rather than b, question mark, a, b. Okay. So we do this. This is gonna make this little line that I've created here a little bit awkward. but still.
And we have A and B here, and we are going to compute the maximum. So if we go down here and say max and pass in hello and world, the compiler is going to try and look for a function that takes two character array parameters. It's not going to find it because we don't have that guy in here, but it's going to see which function can take something I can come up with through implicit conversions. And the compiler is going to see that it can really convert from a string literal to a string view type. And it is going to insert an implicit conversion from string literal to string view, and this function here is going to be called. So we're going to put in an output statement here. We're going to say string view overload called. And if we try and run this program, let's build with GCC, make sure that the build is good. The build is good, so we can clear and run rooster. This is going to show string view overload called. We are able to call this guy here. And again, the message is that we really have a lot of flexibility in how we can set up overloads for a function in C++. And please use this facility to your advantage if this makes things better for whatever application you are designing. I would like to welcome you.
Oh, and that's the end of that lesson. Yep, that's extremely short. That was half an hour for us. And we looked at it. I mean, it's like, I didn't know this was possible. This seems like a very useful and interesting tool that we can have in our arsenal. And then this one we have our... Wait, we didn't print anything with this last function, but that's fine. All we did was we made it print that it's called the string view overload, which is enough to demonstrate that it works. But yeah, the fact that this works in this way, I'm curious how this ended up getting developed, like how they decided that they needed this, because it seems to me, and maybe this is here. Let me try. I want to try something real quick, just a minor thing. I'm kind of... do like this, and then like this, because I'm pretty sure that just having this, if we do... let me do this again. What am I doing? I'm pretty sure if we just do... So like we have a double function as or a double max function. But I'm pretty sure if we just pass our integers through that, it should work. Right? Let me just run it. Yeah, double overload called, and it gives us our max. So I'm I don't think it was because of this specifically. I'm sure there's other reasons to do this. Almost certainly, this seems like the kind of thing that is like you want it to have the same name, but you need different values for one reason or another. Using numbers is a little bit less. It's a little bit less intuitive, but I think that this actually seems like it could be very useful. But anyways, that is that's a pretty interesting lesson. This is going to be... oh gosh, okay. So this is all that we really have in this one today. We're going to be doing lambda functions tomorrow. That tomorrow should be like another like normal quote unquote full lesson. You know, it's going to be, if we look at this, like this one was 15 minutes long, but this next one is going to be like an hour long for the lesson. So it'll be an actual like full day of... I say full day, but you know, it'll be like a normal like classroom day of doing this. Today I'm using this short one as an excuse to try and to see how much of my C++ or see how much of my video my Bard's Tale video I can get done today. So with that, I'm going to go ahead and I hope you guys have. Oh no. Okay. I'm gonna close this. Let me open my little thing. Go to chapter 14, lambda functions, and we're at this. Our timestamp is 16 hours, 49 minutes, and 0 seconds. I think we're at 01, but the chapter starts at 0. So with that, we're gonna call that one. It's short and sweet. Not a whole lot specifically for function overloading. I probably could have done it yesterday in retrospect, but I've been trying. I want to get the Bard's Tale video done, and I'm hoping to get that done sooner rather than later. I think the hope is to get it out by the end of this week. So we'll reconvene with this tomorrow, and I hope to see you tonight for our Warcraft campaign. It'll be a lot of fun doing that. And the rest of the week, I have to make waiting rooms, but I still have to make some more waiting rooms, but I think the plan is to try and finish Warcraft, the canon orc campaign, and we'll be doing some more Resident Evil 2, and Baldur's Gate is continuing, as per the usual. So, anyways, guys, I hope you guys have a good one. I'll peace out. We'll see you in a few hours. Bye.